What's a better way to learn Python than by building something genuinely fun and challenging? Join me as we recreate the iconic game of Minesweeper from scratch, giving you the skills to handle grids, logic, and user input. You'll be surprised at how simple it is to build something so complex. For this video, we will be focusing on the logic of the game, and output will be printing text to console rather than recreating the same aesthetics of the game. As a brief summary, the goal of Minesweeper is to clear the grid without detonating any hidden bombs. You start with a grid of concealed squares and must click to reveal them. When you click a square, one of three things happens. You either reveal a number, a bomb, or an empty square. If you hit a bomb, you lose. If you reveal a number, it tells you exactly how many bombs are in the 8 surrounding squares. You use these numbers to deduce the location of the bombs, flagging them with a marker, and safely revealing the remaining squares until the entire grid is clear. Before we start coding, it's good to start with a to-do list. By writing down the actions we need to do, we can take little steps in coding it out, and having a plan makes things easier in terms of knowing what to do next. At a high level, I see it as two separate sections. The first is the back-end game board, which is the hidden environment of the game board, and the second is the front-end game board, which is what the user sees. For the back-end game board, I can further break down into smaller sections of the task list of things to code as action items to do. The first is the game mode. Based on the official guide, there are 3 modes: easy, medium, and hard difficulty, which will translate to the size of the game board and how many mines there are. The second is to plant the mines on the board, along with the corresponding number hints, which indicates how many mines are surrounding the cell. Thirdly, we will need the code to check the back-end board for the win and lose condition based on the player's selection. Moving on to the front-end user interface, the first would be the environment that the user sees, the board with the hidden cells. Next is the user input. The last item would be the display trackers, such as the number of mines and timer, to record the time taken to complete the game. For the next part, I will code in a way that makes sense to me, so you might see me code in a way that may jump from front end to back end and vice versa. Not to worry, there is no right or wrong way to code it, just that this makes the most sense to me. If you are stuck anywhere, please feel free to pause and re-watch the video. Now that we are ready, let's start to dig in and find those bombs. Firstly, let's start by importing the necessary libraries for the project. We will start by determining the board size, as without it, we won't know the difficulty and how big the playing field is. From online sources, I found out that generally there are 3 difficulties: easy, medium, and hard, with their corresponding field size and number of mines. I will start by creating a function which will return a tuple of the size of the board, along with the number of mines. The function will take an input, and using an if-else code, depending on the input value, will provide the corresponding field size and number of mines. Next, we will create a base board. Let's start by initializing the difficulty based on the previous function. Let's start with an easy board. Next, we will create a base board using list comprehension. We will create a list of underscores based on the second value of the tuple variable called size by multiplying the underscore with it. This will give us a list of underscores, which will serve as the length of the board. This will be iterated through a loop for each value in the first value of the size variable. This will ensure the correct height for the board. We can run it to see the results, which is a board of underscores using a list of lists, with the height and length of the board in accordance with the size variable. This first board will serve as our front-end board that the player sees. Next, let's create the actual board environment with the mines and the numerical clues. We will create another variable for the back-end board, using the same list comprehension we have done for the front-end board. Then, we will plant the mines. We will create an empty list called mines location list first to store the coordinates of the mines. Then, we will loop through the range count of mines and randomize the coordinates of the mine. If the mine coordinates are already in the mines location list, we will randomize another set of coordinates. Once we have confirmed that the randomly generated coordinates are not duplicate, we will mark the board coordinates with X and append the coordinates to the Mines location list. We can then view the board backend to verify if the code is working. Great, it looks to be as expected. Now that the mines are planted, we need to mark the surroundings with numbers as hints. For each cell on the board, we will check the number of mines that are adjacent to it. First, we set the mine counter to 0. This will serve as the number counter that will eventually be populated for the respective cell. Then, we will iterate through all the adjacent cells to the selected cell. As long as the iterated cell coordinate is well within the boundaries of the board, and if there's a mine on that cell, the mines counter will increment by 1. Once the loop is completed, the board cell will be populated with that number. This will be repeated for all the cells, hence you can see multiple loops within loops. Similarly, we can view the board to verify if it's correct. Great, seems to be working well too. We'll now move on to code the section on board interaction. We need a mode of communication with the board so that we can pass instructions to where we want to dig, and it will display the results. We will use an input function and store it as a move variable. To keep it simple for now, we just want to input the coordinates of the cell we want to dig up. As such, the expected input would just be a number, a comma followed by another number. Since the input value is a string, we will split the value, convert the numbers into integers, and store them as a list of coordinates. The input values will be limited by the size of the board. So, using the stored move variable, we will convert it into a choice cell variable, where we deduct 1 from the coordinates. As in Python, the first value starts from 0 instead of 1, while the value we input starts from 1. Another thing you might have noticed is that we swap the positions of coordinates for first and second value in the choice cell variable. This is because usually when we provide coordinates, they would be in the form of x-axis coordinate first, followed by y-axis coordinate. However, because of the way how creating a list of lists is done in Python, the y-axis coordinate becomes the first value rather than usually how we provide it in x and y format. Thus, we would need to swap around to prevent confusion, as we would code subsequent codes in order. You will see what I mean later on. Next, we will code the section on revelation of cells. From the front-end UI in the game, when we click on a cell, if the cell is not a mine, the board will reveal a few surrounding cells along with the selected cell. This is what we want to code in the section. I will create a list and iterate through all the adjacent cells to the selected cell. As long as the adjacent cell is within the range of the sizes of the board, the coordinates will be added to the list. This is to ensure that if a cell along the edges of the board is selected, the adjacent cells that are selected will indeed be within the board and adjacent to the selected cell as well. We can inspect some samples of the list depending on the number we input to see what I mean. Then, we will randomize the number of cells to reveal. As there is a minimum and maximum number of cells we can reveal, we will set a lower and upper bound to it. Since we have seen previously that depending on the location of the cell we select, there can be different numbers of cells available to reveal, we will set it dynamically such that the number of cells to be revealed will change depending on the number of cells available to be revealed. In the event that the lower bound number is higher than the upper bound number, I will include an if statement to set it to lower bound number, if that is the case, else the number of cells to be revealed will be a random integer within the lower and upper bound. In the following part, we will code the action on the board when we click on the cell in the front-end UI of the game. We will set the value based on the selected cell of the front-end board to be the same value as the coordinate of the back-end board. We will decrease the counter of the number of cells to reveal by 1 and remove the coordinate from the list. We can inspect to see how the board looks by revealing one cell. Once that is done, we will make sure that the number of revealed cells are revealed before we move on to the next action. As such, we will use a while loop, where as long as the variable of the number of revealed tiles is not 0, we will randomly select a cell from the list. Then we will check the condition if the cell to be revealed is not a mine from the back-end board, and if currently the cell on the front-end board is not revealed, we can reveal this cell on the front-end board and decrease the counter by 1. The cell revealed this way is a numerical clue. However, if the cell to be revealed is a mine on the back-end board, we will not reveal this cell. Instead, we will skip over this and decrease the counter by 1. This loop will repeat until the counter drops to 0, only then it will move on to the next step. So far, we have coded the sections on the actions to be done, such as selecting a cell, revealing the cells if it is not a mine. Next, we will code the lose and win condition of the game. Let's start with the lose condition. This should be fairly straightforward. Basically, it is just an if statement, where if the cell you selected is a mine on the back end, there is a print of you lose and the front end board changes to the back end board. Once that's done, we can move on to the win condition of the game. This is done via a continuous check against your move, and if the remaining cells on the board have the same coordinates as the remaining mines, it should trigger the win condition. As such, we will need to put this as an outer while loop, checking the value of the game status. We will set the game status variable to 1. While the game status is still 1, it indicates that the game is still ongoing. We will create a check that iterates through all the cells on the board and append the coordinates of the unrevealed cells into a list. We will sort and compare this list against the list of coordinates of the mines. If there is a match, it means that all the unrevealed are mines and you won the game. We will also set the game status to 0 to break the loop. We will also set the front end board to be the same as the back end board, but replace the mines with the letter F to simulate flags planted. With this, we are nearly done. We will now revisit the section of code where we input our action for the board. Previously, we could only dig and reveal the cell. Now, we will add another action that we can take, which is to plant a flag. We can do so by specifying that the first letter in the input would be either AD for dig or F for planting a flag. We can also remove the flag by indicating the coordinates of a flagged cell on the board to remove the flag as well. By including this flag action, we will also need to ensure that our subsequent codes are updated such that we can do a dig action on a flagged cell to reveal the cell should we choose to. Once that is done, we will now modify the print to screen that the player will see. We will update an instruction before the print screen and include a counter for the number of moves taken, the number of mines remaining as a function of the number of mines deducting the number of flags on screen, and the elapsed time to simulate the displays from the actual game. Now that we have coded all the components of the game, we will assemble them in order for the game to be played. After assembly, we can run the code to test out and play the game. We can input a difficulty and put in a few moves. We can also test the lose condition. Finally, we test the win condition as well. And there we have it. We have successfully coded a Minesweeper game in Python. As usual, I have linked the code in the description box for those who are interested in trying it out. And that's the end of the video. Hope you enjoyed it, and if you have any thoughts, feel free to share them in the comment box down below. If you liked this video and would like to see more content of this nature, please be sure to like and subscribe as well. Thanks for watching, and until next time.